to the left.
All right, I will begin with a word of prayer. Heavenly Father, we thank you for this day. Again, I thank you for these students. I ask you to bless our time together and help us to understand the math a little bit better. Help the students to ask good questions as they have them. And we just thank you again, Lord, for your many blessings this day. In your name we pray, Lord Jesus. Amen. All right, so you guys told me problem 40, was it 41? 51. Okay, so problem 51, here's a hint. Suppose you had f of x equal to, let's say, x minus 2 over the square root of x minus 2 squared. And my instructions for problem 51 were to rewrite the formula for this as a case-wise defined function. So the main thing here to notice and to be aware of is that we have a formula for absolute value. So like the absolute value of, x is equal to the square root of x squared. And the way that works is it's minus x if x is less than or equal to 0, and it's x if x is greater than 0. And you can throw equals into either case. It doesn't really matter. They agree at 0. Okay, so that is actually what then? What are we looking at? The example I throw up on the board here. It's actually x minus 2, right? Over the absolute value of x minus 2. I don't know if you saw that or not, but that's what it is. So that is a case-wise defined function. We just have to think about the two cases. What are the two cases here? So either you have x minus 2 is less than 0, so the absolute value of x minus 2 is equal to what? Minus parentheses x minus 2, right? Or if you have x minus 2 is greater than or equal to 0, then the absolute value of x minus 2 is just equal to x minus 2. So those are the cases here for the absolute value of x minus 2. So if you look at it, there are two cases, right? On the one hand, we have x minus 2 over minus parentheses x minus 2 if x is less than or equal to 2. On the other hand, we have x minus 2 over x minus 2 if x is greater than 2. You know what? I can't decide which equality to put in which case. Let's just put it everywhere. There we go. That way I can't be wrong. They match up anyway. I guess if you wanted me to be fussy, I should really put less than on one and greater than on, you could put the equality both places here because it matches up, but generally we need to be careful only to put the equality where it belongs. All right, so can you guys simplify what I have on the board? What is x over 2, x minus 2 divided by x minus 2? What is that? Yeah. Yeah, the top one's negative 1? Very good, yeah. So we got negative 1 if x is less than or equal to, 2. And here's where I get into trouble. So I need to make a decision. Well, okay, that's the problem. That's the problem here, isn't it? So what I really should say is if x is less than 2, right? And 1 if x is greater than 2. Why do I have to do that? In fact, in this 2 here, this is bogus, right? I can't put equals to 2, can I? Why not? I'd have division by 0, right? So to be careful, these should be strict less than and strict greater than, otherwise it doesn't make sense. But there it is. That's how this formula simplifies. It's either minus 1 or it's 1. And it jumps from minus 1 to 1 at 2. This one does. Now your homework problem is very similar. So if you understand this, you ought to be able to do problem 51.
And then it was 42C.
42C? Sure. All right, so 42C. Whoa, yowzers. I'll do something like it. It's like 1 over x squared times, oh, I don't know, x cubed times the cube root of y times y to the 3/4 over x, apparently, something like this. I mean, that's not the problem, but this is similar in spirit to the problem, right? So you're multiplying these things, and the instructions are to simplify it and write it in the form c times x to the a times y to the b, right? So your goal, find the constant c, a, and b. So how do we do that? I would say, what I would do is I would do it one step at a time, right? So I'm just going to kind of, first of all, simplify this. What we're literally looking at is x cubed times, what is y to the cube? What's the cube root of y? It's y to the 1/3, right? Then we've got y to the 3/4. That's all multiplied in the numerator. In the denominator, we have x squared times x, right? Of course, you could have I'm sure most of you would have said, well, that's x cubed. Hey, that's x cubed. So what do we have? Make another step here. That's x cubed downstairs, right? Ah, yeah. So these cancel. So these guys reduce, and we're just left with y to the 1/3 times y to the 3/4. So how does that simplify? We do what? We have to add exponents, right? So you guys got to tell me what's 1/3 plus 3/4. Oh man, I've got no calculator today. A wandering biology student came and demanded of me my scientific calculator in my office, and I'm without arithmetic today, unless you guys want to do it for me. I guess I could figure it out.
Would you?
It's twelfths, right? Yeah?
Yeah, 13/12.
13/12ths? Okay, I'll allow it.
Yeah.
That looks right. Okay.
I'm not sure of
So then what? What are A, B, and C here?
that. C is 1.
I heard a C is 1. So this is C is equal to 1, right? A is equal to 0. B is 13, 12 over 12, yep. So you got to use your imagination, right? Because this has got 1 times x to the power 0 times the y to the 13 over 12, right? So we can always, with these problems, you can always match the simplification against the template and just read off the C, the A, and the B like this. Now, I think C is equal to 1 for most of the problems I write down. But it's fun to make C not be, like for part B, I think C was 39 over 13, right?
Yeah.
Which I think is 3, right?
Yeah. So for B, like, so if you get, let's say you got 39x to the negative 1, y 0, would you rearrange that to where it would be 39 over x to the 1, that way you don't have a negative?
No. As I've done these, you would look at that and then you'd say, this, if I set this equal to C, x to the A, y to the B, then that would imply C is 39. A apparently is minus 1, and B is equal to 0. Now, what you might be thinking about is a lot of times there's problems in the textbook or something where the instructions are simplify this expression using positive exponents, right? So that would be the different instructions. If you had instructions simplify using positive exponents, then you would want to rewrite this as, 39 times y to the 0 divided by x, like that.
And then my
But
last one was 54.
54? Are you guys excited about the quiz? No? Oh. Find the domain of the functions given below. All right, so that one, right? So how do you find the domain of a function? So A, I think it was something like f of x is 1 over the square root of x squared plus 6x plus 13. Is my 39 unclear? What is it? What's happening?
Where did the 1 from C come from in the last question?
This one?
Yeah, why is C 1?
Because there's 1, this is equal to 1 times x to the 0 times that. So the constant in front is just 1.
Okay, so the implied 1.
Uh-huh.
It's not written, but it's there.
It's always there.
Okay.
There's a 1 multiplying you right now.
So true.
And there's a 0 that's being added to you all the time. You just don't feel it. But it's there. Right? Like the wings on an elephant, you know? What? That's what I had a class once with a hilarious Russian, I think he was Russian, physicist. He had a very bad stutter. I mean, his stutter was strong. And so he was telling us this, and he's like, I forget what it was. It was something he's like, well, he stuttered a lot. I won't do that because, of course, that's politically incorrect. But imagine stuttering. And then he's like the wings on an elephant. And we're like, what? He's like, you set it to 0. I'm like, okay. So, in the same way, you have wings. They're just set to 0, right? Do any of you have surgically, have you altered yourself surgically to add wings yet? Anybody? No?
Yeah.
Oh, you? What's that?
They're set to 0.
Oh, they're set to 0. Let's not do that. This has become an advertisement for Red Bull? No. All right, so this is not your homework problem, right? But this is like your homework problem. How would you, what would the problem be? If there's a problem with the domain, what would be what? Division by 0, right? Or if we're feeding something negative into the square root, also problem, right? How do you decide whether or not this thing is ever 0? What do you got to do? Factor it, right? If you could factor it, you could tell. It doesn't factor nicely, so what do we do?
Complete the square.
Complete the square, right? As you know, a day is not complete in here without completing the square. Let's see here.
I agree.
So that's x plus 3 squared. Subtract 9, so you end up with a plus 4, right? So what does this mean? If we complete the square and we get a square plus a number, can that be 0? It can't, right? So what's the domain of this function? Right, so the domain is all real numbers. And I think the one in your homework is also like this. I mean, the completing the square is different, but
So why is it all real numbers? Because of the square?
because there's no division by 0 for that one. In contrast, here's a hint for part B, something like f of x equals the square root of 16 minus x squared, right? This one, what's the domain? We look at real functions of a real variable, right? So we need to be inputting a real value into the square root. What do we need? We need to solve 16 minus x squared greater than or equal to 0, right? The same was true of part A, right? We were also solving the inequality, x squared plus 6x plus 13 greater than 0. It's just, I shortcut all that by completing the square.
Is it just 4?
Just 4. See, how do you solve a quadratic inequality? What's our method? We had a method, right? So this is 4 minus x times 4 plus x greater than or equal to 0. We draw our number line. We put our critical numbers, namely 4 and minus 4, right? And then what do? Plug in a point, right? Like plug in 0, what do you get? We get positive or negative at 0. Yeah, because we get 16, right? So 16 is greater than 0, so it's all pluses up in here. And then on the side cases, we flip to minus on the other sides there. So what's the solution set to this? X is in minus 4 to 4, right? So what's my domain? Right. So this one has domain minus 4 to 4. Now, should the 4s be included? In the minus 4, should they be included? Is it okay to have square root of 0? It is, right? So those should be included. Sidebar, b tilde, right? If you had f of x equals 1 over the square root of 16 minus x squared, yeah? Then the domain, let me call this f tilde. What would be the domain of f tilde? It's the same inequality, right? But now you have to do what? You have to avoid putting 0 in, right? So it's a very similar problem, but the domain in this case, yeah, exclude it, exactly. Exclude the 4 and the minus 4. Now your homework is not that, right? But that's a related problem I could ask you.
Question.
Sure.
So, why are you able to kind of bypass the square root and the?
So why am I able to?
Are you doing is it because you changed it to plus and minus?
I bypass the square root because, like, when we come up against the square root in a formula, the issue with that, right? The reason that can limit our domain is that if we feed the square root anything but a positive or a 0 number, right? It has to be the input has to be non-negative. Otherwise, we'd be looking at the square root of a negative number, which would mean that we're not dealing with a real function anymore, right? So if I have a square root, I can ignore, like, even if there was, look, I could have added x to the, what year were you born?
2003.
2003. I could have added x to the 2003 here. That wouldn't have changed it, right? I could, add, whatever, 13, etc. As long as the things I'm adding don't put any conditions on the formula being reasonable, all I have to do is focus on the square root, because that's what's the limiting thing that's narrowing the x which make the formula reasonable, right? That's our method is just to try to figure out which x's can I put into the formula and not arrive at some sort of contradiction of arithmetic, which for us at the moment is either division by 0 or the square root of a negative number. Now later in the course, we'll add to that list natural log of a negative number, but we don't know what a natural log is at the moment, so strike that from the record, right? Okay. Hey, let's get started on the quiz. Should I leave the camera on and I was thinking about, I was going to start videoing the classes taking my tests and quizzes so I could, catalog the suffering for YouTube, But I really, to make that good, I'd have to bring the camera up in the front, and zoom in on people's faces and their furrowed brows. And I'm just kidding. I'm going to turn the camera off here in a minute. Thank you. Sorry, none for you.
I figured.
I mean, unless you want one. I don't know if I have enough, though. Find out soon, huh?
All right, Mr. Sheriff, what are you doing?